Hello, Mikey here, Whiskey Delta Zero Oscar Mike. I've been promising for some time to take people through the upgrade and recalibration of the FX-4CR using F5BUD's V2 firmware. Last time I walked through the upgrade process and gave brief first impressions of Daniel's user interface. Today, at last, we're going to go through the actual calibration. First of all, at the end of my last video, I left out a step. When powering on for the first time, I was supposed to hold down the power button to force it to initialize its EEPROM memory entirely. I don't think that works after the fact, so instead, first thing I'm going to do is walk through all three specific resets available as part of the first stage of this. Before I do that, though, I'm going to talk a little bit about the gear we're going to use, then I'm going to get started. So let's talk gear. First up, we've got the power supply. For this, I am using a bench supply I had around, and I've got it set for 12.8 volts and 5 amps max. The really important part, though, is to have a supply that's going to put out a predictable voltage. We're actually going to test that before we use it. This is a trust but verify kind of situation. And then we're going to use that to calibrate the radio's internal power meter. For that testing, I have this very simple, cheap multimeter. The first thing we'll be doing is calibrating the internal power meter. As I said, in order to do this accurately, we need to be able to know exactly what the power supply is putting out, which is why I'm using a bench supply and not a battery. The next thing we'll be using is a TinySA, in this case a TinySA Ultra. These are fairly inexpensive, and you don't need one of these every day, but every now and then you need it, particularly for something like this, where you are trying to calibrate equipment or test equipment. You will see people use these when they test radios for spurious emissions, for example. You can use something else for the signal generator side of this, but I happen to have a TinySA, so that's what I'm using. And I'll be using it in lieu of a power meter to gauge the power we're putting out. I've actually tried it both ways and decided I like the TinySA method better, so that we do not blow away our TinySA or in the other direction our radio when putting out signals between them. We are going to use a pair of attenuators. There is a 30 dB attenuator and a 20 dB attenuator here. You may notice these look an awful lot like dummy loads, and in fact I'll be using a dummy load too. I'll show you that in a minute. And that's because they essentially are. They're just sized not to pull the whole signal down. They're sized to pull some of the signal down and then let some of the signal through. You will also notice that there's quite a lash up going here. These two devices, these two units, both have Type N connectors, which I don't use for anything else in the world. So I'm having to adapt on one side to SMA and on the other side to BNC so I can hook up to the radio, which of course uses BNC. So the SMA is for connecting up to the TinySA, and the BNC is for hooking up to the radio. I'm using the TinySA Ultra, which according to the instructions requires 50 dBm of attenuation. It's a little more resilient. If you're using a TinySA Basic, you'll actually need two 30s for 60 dBm total. These are surprisingly inexpensive. I think I paid 20 bucks for each of these, maybe, over on Amazon. And over the course of your ham life, you may find other uses for them, including calibrating other radios. You can also possibly borrow them from other hams, or be that ham other people can borrow them off of, depending on how you choose to do it. I decided to go ahead and buy them and be the ham that other people can borrow them from. The last thing we're going to need that I don't have out on the table yet is going to be a second radio. This can be a receiver only device like an RTL SDR, but in this case I'm going to use probably my G90. I've used a couple of different radios while rehearsing this, and I've decided maybe the G90 is the best way to go. We need to be able to listen is the important part. You want to be able to hear the audio and make sure when you're doing the adjustments that you are not getting a spur. So what we're going to do is we're going to turn down a little bit. We're going to turn 48 kilohertz away. So if we're putting out a signal at 3.6 megahertz on the 80 meter band, we want to listen at 3.552 megahertz. And then when we key down, we don't want to hear a lot of that signal. We want to hear as little of that as possible. So we are going to adjust two coefficients, which relate to the I and the Q, and that will reduce what we put out. Similarly, we're going to use a signal generator, the TinySA again, and then we're going to adjust the RX, mag, and phase to reduce the amount of spurious input we receive. So with all that ado done, I'm going to go through the 3 separate resets I already mentioned. So for each of these, I'm going to hold down a key combination and then continue holding power while I hit F to say, yes, go ahead and do it, and wait until it says finished. The first thing I'm going to do is I want to clear the user settings without clearing memories or CW messages. And I'm going to do that by holding AB and power. There we go. You see it says settings reset. I'm going to continue holding power while I hit F, finished, and let go. So it powers off again. So I don't have to power it off. It's smart. All right, next, in my case, I don't have any need to save memories. In fact, I don't think I have any memories to save, but just in case, I am still going to go ahead and hold down MV and power and F, and it says finished. And then lastly, because I have monkeyed around with the calibration as part of rehearsing for this, I am going to go ahead and clear the calibration entirely. And to do that, you hold down AM/FM and power, and it says calibrate reset, and I say finished. All right, so now we have a radio that is completely cleared, and we can start monkeying with it. I've got this set up as a voltmeter. I've got my probes. Red is active, black is ground. Got black to the shield. And we see on the voltmeter that we are 12.82 coming out, while the power supply says that it is putting out 12.8. That's what we needed to know. We are putting out 12.82 from the power supply. That's what we should calibrate to. So now we're going to calibrate the voltmeter. So now we know the power supply is putting out 12.82 volts. That's what we want to target. So now I'm going to turn on the radio by holding RIT down and power, and that puts us into service mode, which is where we want to be. And then I'm going to hit menu, and now we have the service menu up, and this is where we're going to be living for the rest of this video pretty much. AF changes value, tune changes what you're actually adjusting. What we want for this right now is the volt calibration. So right now it says we are at 12.88, but we know that we're at 12.82. So now I'm going to use AF to adjust, and this is one of those things where it's inverse. So I'm going to turn clockwise to actually turn the voltage meter down. And we want that at, there we are, 12.82. 2632 is the magic number, it turns out, on this unit to get 12.82 calibrated. That wasn't so scary, right? So the next thing we want to do, and this is the first place we'll be using the TinySA, which I'll set up in a minute, we'll be using it as a signal generator, and for safety's sake, we will be following the instructions and using the attenuators. Okay, so it takes a little doing to get them both on camera, but I think it is useful to have them both on camera. So I have done what I can to make that work. I'm going to turn the TinySA on. And I'm going to go ahead and tell it that we want it to be a signal generator. So I'm coming down here. Hopefully the autofocus will work. I'm coming down here to mode and selecting signal generator. All right, I think that'll work. All right, so I have this set up. I've told the TinySA, hey, we've got an external gain here of minus 50, and we want the level to ultimately be 73, minus 73. So I'm going to turn ourselves on again, go into the menu, and for this we want the RSSI calibration. We also want to be tuned to the right frequency. You'll notice here I am clicking Tune to move up in band, and we would click AF to go down in band it's got presets for the frequencies it wants for all of these. You will also notice if you listen, there's a bit of a pulse there. That's because I am using a lot of noisy equipment here on my desk, and that's probably what we're hearing. But it won't affect what we're doing here, or at least it shouldn't. The noise level's pretty low. Anyway, let's go ahead and click Output On. Look at that, we've got a signal. And now we want to adjust that signal to minus 73 dB. And there we are. The magic number is 91, gets us to minus 73 dB, and gets us close to an S9 on the S meter, which is what we want. Okay, so for the next step, we are going to be doing, and for this step, you definitely want the attenuators in place. So I've got them still set up. I'm going to switch back to a mode of spectrum analyzer. So here we are back at 80 meters to do this first test. And back in service mode. And for this we want, no, we're not doing that yet. We want 80 meter TX power is going to be the first place we start. But we also have to set up the spectrum analyzer. We want to set the frequency. We're going to set the center to 3.6 megahertz. We're going to set the span real short. I'm going to set it for 100 kilohertz. That's actually even longer than it needs to be honest. I'm also going to tell it once again that we have attenuators hooked up. So it now knows to subtract 50 from whatever it's detecting. The target we're looking for here is 40 dBm. And when I key down, what we should see is something close to 40 dBm on the TinySA. And we're a little shy, right? Actually, no, we're not shy. We are actually putting out 40, but we don't think we're putting out 40. So the first thing we need to do... Actually, I'm going to walk that back. So according to the TinySA, we are putting out 40. That's what we want. I'm going to do that again just to show you. TinySA settles down, and sure enough, we are at 40 dBm, 39.2, so I'm actually going to turn it up just a little. Because if you can see the numbers in the top, we're not quite at exactly 40. I'm going to let it have a break. You don't want to run it too long. By the way, the attenuators will get warm, putting 10 watts into them all the time. So take a break every now and then. The TinySA takes a couple of minutes sometimes to catch up. Now we're a little over. This thing, the radio still says we're only at 9.92 watts, and we'll deal with that in a minute. Oh, no, it settled down. All right, we're at 39.7. Still at 39.7. Now we're consistently just above 40. I'm going to turn it down a little bit. Take a break. Run it again. So the radio thinks we're putting out 11.42 watts, but the TinySA says we're only at 40.2 dBm. Sometimes a little higher, but not much. So I'm going to crank that down a little bit yet. I don't want to be too far above our target. But this is only half the calibration. Because of course the radio thinks it's putting out more than the TinySA does. And now we're back down just below 40. I'm not actually sure which side of this line we really want to be on. Conservatism says I should probably leave it at the low end, but I want to see if I can get it to the point where we're just over the line to 40.2. Now we're consistently seeing just over 40. The radio thinks we're putting out a little more than that. So the next thing we're going to do is actually calibrate the internal watt meter by going over here to watt cal, and we're going to adjust this until it agrees we're actually at 10 watts. And you'll notice the TinySA isn't really changing much. That's too far. That's about right. 1183 is the watt calibration on here, and for TX power, 390 is the magic number. So now, the next thing we do is we do the same thing for each band. So in the TinySA, because we're going to trust but verify on the TinySA, I'm going to leave the span alone, but I'm going to keep changing the frequency. So I'm going to go, the new center is going to be 5.352 megahertz. This is on 60 meters. And here we go. We're pretty low there. And TinySA says we're at 39.2 dBm. So we're going to turn this up and get ourselves to 10. Because now, at least in theory, the internal watt meter is correct. It is measuring itself correctly, which means we can, in fact, do all the other bands based on the internal calibration. But I've got the TinySA here to make sure that we're never too far off. I'm okay if it's a little off on one or the other. And here we are. We're at 10 watts, a little over 10 watts, and a little over 40.2 dBm. I think that's good. So now we're going to do it again. We're going to go up to 40 meters, change the center to 7.1 megahertz. Key down. We're closer there. We're at 9.3, but we are still off, so we're going to turn that up, up, until we're touching 10. 792 is my magic number for 40 meters. Go up to 30, 10.1 megahertz. Now we're way up, we're way over, right? That's 40.6 dBm and almost 12 watts of power out, while we say we're putting out 10. So we're going to crank that way down, and that magic number is 630. And that gets us 39.6 dBm on the TinySA, surging up to 40.1. I'm going to call it, now it's stable. Yeah, we're going to call that good. All right, now we'll do 20, 14.1. That's way low. That went a little far. You don't really want to overshoot too much. There we go. Almost exactly 40 on the TinySA, and a little more than 10 watts. We'll turn that down just a little bit. There we go. There's 20 meters. We'll go up to 17 meters. Center, 18.1. We're just a little low for that, and that's interesting. There, TinySA has us a little higher than the watt meter does. There we go. I think that's a little better. On 17. That's okay. The TinySA is not that precision a device. All right, so there we go. Go up to 15, 21.1. That's low. That's requiring the largest boost we've needed so far. But there we are. 1033 is the magic number there. 12 meters. $24.9. That's a little low. Although the interesting thing is, for 10 meters, the internal watt meter, there we go, The internal watt meter says we're low. The TinySA says, oh no, now it says we're spot on. All right. Either way, 1701 is the magic number. Enterprise, gotta love it. Now keep in mind, by the way, your numbers will be different, otherwise this would not be necessary. Don't just plug my numbers into your radio, please. Now 6 meters, and 6 meters is a little different because we only get 5 watts out of 6 meters. I'm going to adjust the TinySA's frequency. We're targeting 50.1. Oop, that's not the one I want. I want the center, 50.1 megahertz. And for that, we are looking for a dBm of 36.99, which may sound counterintuitive, but remember that decibels is a logarithmic scale. It is not 1-to-1, which is also why there's not as much change in the dBm as there is in the wattage when we're doing this. So here we go for 6 meters. We're aiming for 36.99 on the TinySA. We're actually pretty close, and we don't get 3 decimal points, so it already says we're 36.9. So we're not too far off, so we will go just based on the watt meter and not worry about the TinySA too much, and get ourselves to 5 watts calibrated. And there we are, 1866. That's almost a little high. We'll drop it down a little bit. What I've discovered is that once the components heat up a little bit with use, as you're sending a signal through, the power does change. So you do got to let it run for a little while. You'll hear the fan both on, in my case, you might be able to hear the fan on my power supply going, and the fan on the radio itself has been going a little bit. The radio is a little warm. The attenuator, particularly the forward attenuator, the 20 attenuator, is a little warm. That is to be expected. But now we are calibrated for transmit power. I'm going to go ahead and set us back to 80 for our next round. I also, however, need to get out of that menu and change. Oop, I didn't mean to do that. That's all right. It did what I wanted, which was get the power back to where we want it. We want the power back to 10 watts for our next test. So the next test, you may have noticed on the TinySA, we were getting spurs. We were definitely seeing spurs on both sides. That tells me that I actually could use the TinySA to test this. But I'm going to do it the way it says to do it in the manual. I'm going to go get my G90 out and set it up. Get a dummy load on here and a small antenna on the G90, and I'll be back to do the IQ balance testing. All right, after a whole bunch of rigmarole, I am back. I wound up not being able to use the G90 for this. I forgot just how susceptible the G90 is to interference of all kinds. And it was getting overwhelmed being so close to the radio, and it needs to be close to the radio and the dummy load for this to work. What I wound up doing instead was getting my RTL SDR stick, the RTL SDR V2 stick that I really haven't been using, and getting it set up on my laptop. And my laptop is a Linux laptop. I've never set it up on this laptop before. I had a whole bunch of stuff to do there. It was involved, but I've already tested this. I've rehearsed it a little bit. It works. So now I can go through this part of the process with you. Over my voice, you should be hearing the background noise that we're getting down here. We're on 80 meters. That's where we start. That's where we start for all of these things. And I've deliberately detuned, having already fixed this once, I've deliberately detuned it. I've also deliberately turned down the volume on the radio, which is not a step they actually tell you to do, but otherwise it's actually kind of hard to tell, unless your ears are really good, better than mine, or you're using headphones or something. It's actually difficult to tell which one you're hearing. The idea here, what we're working for here, is we are tuned to 3552 instead of 3600 on the receiving end. So we're detuned by 48 kilohertz. We do not want to hear the signal. But right now, if I key down, you can hear it right on the line. Now I'm looking at the screen. Here's the waterfall on the SDR. I'm using PySDR for this. And you see at 3600 is the main spike, but then you can definitely even see it on the waterfall. And we want to get it so that that is not really audible or visible. So here we go. You can hear it getting fainter. You can see the trace getting fainter. It's not quite gone, and now it's coming back, in fact. So we're going to go back, because we want to get that as low as we can get it. We may not be able to get rid of it, but we want it as low as we can get it. That appears to be about the bottom. That's 972 on the screen. And now I'm going to do the same thing for TX phase, which is the next one. I just turned tune right. And we're going to try to get rid of the rest of it. Or we're going to make it at least as quiet as we can make it. And in fact, the quietest we can make it, that's about it. 1008 on the phase. So let me show you what it shows on the radio. There's the phase, there's the mag for 80 meters. And now, of course, we do the same thing again for all the others. We have the radio tuned to 5352. We want to tune the SDR to 5304 kilohertz. And now we're just going to do the same thing. That's actually got quite a spur going on. That's very visible spur. So we're going to try to tune that down, get that as low as we can. I feel like 983 may be the lowest there. Yeah. And now we'll go to the phase. Same. Went back to mag to see if I can get that lower, because that's still very loud. And granted, I do have the volume up quite a bit, because I want to be able to hear it. Deliberately going to weird numbers here. Yeah, that just makes it much worse. Looks like the 970s are the best bet for that. Oh, there we go. That phased it out almost entirely. So 1006 is the magic number there. I got to tell you, looking at the screen, 60 is actually pretty noisy on this radio. Not sure why. I hadn't seen so much noise elsewhere, but 60, that's not the only spur we've got on 60. Let's just leave it at that. But that's the magic number on 60. All right, let's go to 40. So that's 7100 on the radio and 7052 on the SDR. Do the mag first again. I feel like that's about right. All of these numbers are coming into similar ballparks. Yeah. Now we'll go to phase, and we'll see if we can phase it out entirely. We've had a lot of luck around 10,006. It's just about gone. The nice thing about doing this with an SDR is I'm hearing it, but I am also seeing it on the waterfall and on the screen. And so if my ears are playing tricks on me, I can also look at the levels that I'm seeing and see it on the waterfall, and that's pretty cool. All right, so I think that's the best we're going to get on 40. Let's go to 30. So that's 1010 on the radio, and that is 10052. Yep, still works. All right. Oh, I'm doing the phase first and not the mag first. That's why. Sorry about that. I should have switched back to mag. Oh, that's nice. So on this one, we get down to a mag of 970 and the phase 1076. Yep, that's about right. That's pretty quiet. All right, let's go to 20. So that's 14100, and on the SDR, 14052. Here we go. And we'll do a mag first again. Once again, it looks like 970, 969, 970 is about the right spot for that. We'll give it a break. And so once again, 10,006 or 1,006 is about the best phase, but I'm still hearing more than I like. So let's see, now that I've got the phase adjusted, if I can, yeah, that's better. See, it pays to go back and forth a little bit. All right, now let's do 17 meters. So now this one's a little weird because we're going to be listening technically out of band. But we're listening at 18052. And of course, we're all local, we're on dummy load. Even when we do this the other direction, it will be fine. But, you know, don't do this out at a park, is all I'm saying. All right, we're going to do mag first. Once again, we're going to aim for the 970s because that's been our target for all of these. About 968. And 1006. These are surprisingly consistent. Or maybe I shouldn't be that surprised that they're consistent, but these are pretty consistent. Now we'll go to 21100. On the SDR, that'll be 21052. We're just going to do the phase up to that and drop the mag to the 960s. Because at this point, almost all of them are coming in at very similar numbers. That did it. Go to 12. Of course, 12 starts differently. 12 is 24,900, so we'll be doing 24,852. Same thing again. I'm just going to go for phase at 1006 and the mag down to 9. So this one's fooling us a little bit. The low point is actually at 965. And the phase actually drops out at 1004. So this is why we do every band, even when they look consistent, is that one wasn't perfectly consistent. We'll do 10. 10 meters takes us to 28052 on the SDR. And that one's interesting because we've got a DC tone right on our line, even though we're not doing anything else. How's that for annoying? But we actually have a tone on 28052 already that I think must be a DC tone, and I'm not sure how to get rid of it. So we're going to have to do some guessing here. You know, that actually mostly worked. Now we're just down to the tone we had before. Yeah, it is a little hard to tell, but I think we're going to call that good for now. And I may have to redo it separately, but that's the theory anyway. All right, now we're going to do 6 meters, which I think the SDR, oh yeah, the SDR can do anything. So this is an RTL SDR, it can do literally anything. And there we also have a tone in the middle of everything, which is annoying. Yeah, this number is very different. There we go. So we're all the way down at 938. And the phase is closer to just the baseline 1000. Yeah. All right. That's all the bands for the TX side of the calibration. Now we have to do the RX side of the calibration, and that requires setting up our signal generator again, and I'm going to go ahead and do that and get back to you in a moment. Whew, that was noisy. All right, I'll be right back. All right, we're in the home stretch now. Now we need to tune the same thing on the receiving side. Magnitude, I don't think we have to do phase. Yeah, magnitude and phase. We're going to be listening. We're going to be listening on what we consider our main frequency, and the tone generator is going to be generating at the 48 lower than what we should be listening to. And this is to make sure we are not receiving things that are out of magnitude and out of phase for what we want to receive. So the signal, the TinySA is set up as a signal generator again. It is set up with the attenuators again. So it is set up with 50 dB of attenuation. The output level we really want is minus 73 dB, but the attenuation blah blah blah. Frequency is set for 3552, and we can hear it. We want to hear less of it. That made us hear more of it. That's making us hear less of it, and less of it, and less of it. About 1020 it goes away, but not quite. So now we'll use the phase. And now it's gone. And perhaps not surprisingly, those are almost the inverse of the numbers we were finding on the transmit side. I don't know if that's significant or not, but we'll find out. Anyway, that sounds good. And now we're going to go to 60, which means that this... All right, so here we go. We're at 5.304. On the generator, we're at 5.352 on the radio. We can hear much too much of it. That's pretty good. And that's just about gone. All right, let's do 40. So we want this to be at 7.052. I do like the fact that these are coming in pretty consistent. I like having targets. I think that's good. And I think that's gone. All right, 30. There we go. Now we're set correctly again. All right. We want that in the 1020s. Yeah, once again, we're around 1024. And about 994, 993. That's gone. All right. 14.052. Just going to go ahead and... Whoa! That's not what I wanted. There we go. We'll just go ahead and set this for the 993. We'll go back to mag. And set that for 1024 or so. There we go. Do 17. Keep doing that. I don't know why I keep doing that. I think we're still right in the mid 1020s. Maybe not. one's harder to get rid of, isn't it? There we go. Yeah, there we go. I gotta be honest, I might go back through and try to tune for that level of silence at some point. But these are pretty good numbers. We're doing all right. 21052. That's our magic. All right, almost there. Do 10 meters. 28052. All right, that's that, and finally 6 meters. And there we go. That's it. We've done it. We've finally done it. The radio is now calibrated. We can leave the service menu. What's left to do is to back up those numbers to make sure that we have them recorded so that the next time we need to reload them, because sometimes he changes the storage format but doesn't really change the math, so that the next time we load new firmware that requires him to change the format, we can just reload the numbers we were using and not have to go through all of that again. So I'm going to see if I can set up to do that, because he's got instructions for how to do that with terminal. Alright, so I tried several times to make Minicom, which is a very common Linux serial program, work with the radio and keep RTS low, which is the main trick. If you don't know what that means, don't worry about it. The point is I couldn't do it. And if RTS is high, it considers that to be the equivalent of push-to-talk, which means it's trying to transmit. Fortunately, I did remember to keep the dummy load on it. Otherwise, the SWR would have been rather high. Anyway, point is, I couldn't do it. So my recommendation, quite honestly, is to just write everything down. Write down the numbers. That's what I'm going to do after I'm done with this video, is I'm just going to write down all the numbers we just went through. It's not that hard. It's not that many numbers. And there's a handy table in the manual in case you forget what you need to write down. That, in a nutshell, is the calibration procedure. Was it super easy? No. Was it super difficult? Also, no. And some of it would be easier if it was something I did all the time. It's difficult in part because it's not something I do all the time, and even after doing it here, it's probably not something I'm going to do very often, which means it is still not going to be something I'm going to do all the time. It's still going to be something that I have to think about. That's one of the reasons, quite honestly, that I decided to make this video in the first place, is knowing that I'm not the only person who feels that way about these kinds of procedures, but to show you that it's not that hard. You can walk through it, you can do it, just like I did. And then you've got the new firmware, fully configured, fully calibrated. My next video, I am going to do one of two things. Either I'm going to take it out to operate and actually then do a review based on its operation, or I'm going to do a sort of survey of the screen and the user interface the same way I did with the older firmware. I don't know which one I'm going to do first. I'm probably going to do both, just not in one video. But first, I got to find the time to edit this video and get it up for you. So that is what I'm going to get started on next. I hope that you've enjoyed this video. Please remember to like and subscribe if you like this channel and what I do here. Take care.